This is problem number 10 from section 3.2. In this problem it says, does the parabola y equals 3x squared minus 32x plus 4 have a tangent whose slope is negative 2? If so, find an equation for the line and the point of tangency. If not, why not? First thing we do is find the derivative. So dy over dx is going to equal f of x plus h minus f of x all over h. And I should have said limit here. Limit as h approaches 0. So that's going to equal the limit as h approaches 0. Plug x plus h in. I get 3x plus h squared minus 32x plus h plus 4 minus, I subtract the function because that's f of x part, right? 3x squared minus 32x plus 4 all over h. So this is going to equal the limit as h approaches 0. I know x plus h squared is x squared plus 2xh plus h squared. All right, we've done this a few times. We know that that's what x plus h squared is. So that's 3x squared plus 2xh plus h squared when we plug in x plus h squared, the expanded version. I distribute the negative 32, I get negative 32x minus 32h plus 4 minus 3x squared plus 32x minus 4 all over h. I can start canceling, and I see that negative 32x and 32x cancel, 4 and negative 4 cancel. So I end up with limit as h approaches 0, 3x squared plus 6xh plus 3h squared minus 32h minus 3x squared all over h. 3x squared and negative 3x squared cancel, so we end up with limit as h approaches 0. This is 6xh plus 3h squared minus 32h all over h. Factor an h out of the top, so you get limit as h approaches 0. When you factor the h out, you get h, 6x plus 3h minus 32 all over h. H is canceled, and you're left with 6x plus 3h minus 32, the limit as h approaches 0. When you plug 0 in, that cancels, and you're left with 6x minus 32. This is the derivative. Now they're asking us to use the derivative and determine, does this function have a tangent whose slope is negative 2? So how do we tell if it's got a slope of negative 2? Well, this is the derivative. So we're going to essentially set it equal to negative 2 and solve for x. So if we add 32, 30 equals 6x, divide by 6, it tells us that at x equal 5, so at x equal 5, our parabola has a tangent slope of 5. Of negative 2. So they want the equation. So let's go ahead and write the equation. So to write the equation, we say y equals negative 2x plus b, and we plug in the equation, or we plug in the point. Well, before we do that, we got to figure out, all right, this is the point we got to use to get this equation. We got to figure out the y value. So let's find the y value by plugging the 5 back in. So we're going to say f of 5 is equal to 3, 5 squared, minus 32 times 5, plus 4. 5 squared is 25, so this is 75, minus 32 times 5 will be 150, 160, plus 4. So 75 minus 160 is 25, that's negative 85, plus 4. So that's negative 81. So the coordinate where this thing has a slope of negative 2 is, we're going to write this information here. This is 6x minus 32 is the slope. We're going to say the coordinate's 5 at negative 81. That would be the point of tangency. Now we're going to plug that in, so negative 81 equals negative 2 times 5 plus b, so negative 81 equals negative 10 plus b. Add that over, you get negative 71 as b. So y equals negative 2x minus 71. 71. I'm going to write that better. Y equals negative 2x minus 71. This is the line that is tangent at x equal 5, negative 81. So at x equal 5, negative 81, this is the line that's tangent there. So yes, it has. So it asks a question. Does it have a slope of negative 2? Yes, we did that right here. We found the x value at 5 has a slope of negative 2. And it wants us to find an equation for the line and the point of tangency. So the point of tangency, then we plugged in 5 here to find the y value. Got negative 81. So 5, negative 81 is the point of tangency. We use that point to write the equation for the tangent line at that spot.